Dear students, in this video we will deal with next carbohydrate in the series, that is disaccharides. As we have already discussed, the disaccharides are the carbohydrates which on hydrolysis gives you two molecules of same or different monosaccharides and have general formula C12, H22 and O11. Three common disaccharides have been given here: sucrose, maltose and lactose. Sucrose on hydrolysis with invertase enzyme or an acid gives you two molecules, one each of glucose and fructose. Maltose on hydrolysis with an enzyme or acid gives you two molecules of glucose, and lactose on similar hydrolysis gives you one molecule each of glucose and galactose. Now let's see the formation of a disaccharide here and try to understand it with the help of a diagram. Disaccharide involves the condensation reaction between the two monosaccharides, in which, with the elimination of a water molecule, in which one monosaccharide molecule acts as a hemiacetal, that is aldehydic, with aldehydic group, and other acts as an alcohol, because it involves the formation of an acetal from an hemiacetal and a alcohol. Hemiacetal means half aldehydic group, and the reaction hemiacetal means the compound formed by the reaction of an aldehyde and an alcohol, and this results in the formation of a new bond between two monosaccharide units, that is called as glycosidic linkage. Now we will discuss two disaccharides here. Number first is maltose, and maltose is also called as malt sugar and is a reducing sugar. Why it is called malt sugar? Because it is obtained by the partial hydrolysis of the starch in presence of enzyme diastase, and diastase is present. This enzyme is found in the malt, that is sprouted barley seeds, and that's why it is also called as malt sugar, maltose. Now let's see here. It is a reducing sugar, and since it gives two molecules of alpha D glucose on hydrolysis, it must be composed of two molecules of alpha D glucose, or two units of alpha D glucose. So here you can see the two glucose units in maltose structure. This is the first glucose unit and this is the other glucose unit. Both are linked together by a alpha glycosidic linkage between C1 of the first glucose unit and C4 of the second glucose unit. The carbon 1 of one glucose unit and carbon 4 of another glucose unit is connected by a similar glycosidic linkage, as we have discussed earlier. And this is the Haworth projection formula of maltose. Now let's come to sucrose. Sucrose is a non-reducing sugar, and it is the most widely distributed disaccharide in plants, commonly derived from beetroot or sugar cane. It is a color crystalline water-soluble substance, and its aqueous solution is dextrorotatory. On hydrolyzing with this aqueous solution with enzyme invertase in yeast, it gives you two molecules, one each of glucose and fructose, which either of them on hydrolysis with enzyme or on reaction with or in presence of enzyme zymase will give you alcohol, that is ethanol, and carbon dioxide. Now it is a non-reducing sugar, and its aqueous solution can be hydrolyzed with the help of enzyme maltase as well as invertase. Enzyme maltase hydrolyze only alpha glycosides and invertase only beta fructofuranosides, and since it can be hydrolyzed with both, it must contain a 6-membered ring, that is 6-membered glucose, and a 5-membered fructose unit is present in sucrose, and both are linked together by an alpha beta glycosidic linkage. As you can see from the diagram here, this is the glucose unit, the first carbon atom of the glucose unit and second carbon atom of the fructose unit. Glucose is having alpha linkage and fructose having beta linkage. Both are linked together by an alpha beta glycosidic linkage. Next term is inversion of the cane sugar or an invert sugar. Sucrose is a dextrorotatory compound, since its specific rotation is plus 66.5 degree, and on hydrolysis with an enzyme or acid, it gives an equimolar mixture of D-glucose and D-fructose. D-glucose have a specific rotation of 52.5 degree in plus, and fructose has minus 22.4 degree specific rotation. If you will sum it up, you will get the specific rotation of the entire solution as minus 39.9 degree. That means the entire solution is becoming from dextrorotatory to levorotatory compound, and the optical nature of the solution is getting inverted. So since the optical nature of the solution is inverted, this process is called the inversion of cane sugar or sucrose, and equimolar mixture thus obtained. This mixture of glucose and fructose is called as invert sugar, and the entire process is called as inversion of cane sugar.